When you need a pre-flight weather briefing, you'll probably take up residence in your favorite easy chair and let your fingers do the walking to your telephone for a call to flight service or to your computer keyboard to connect with Duet. But what about once you're airborne? In flight, you can get weather through two-way communications or through broadcast recordings on selected VORs. Now, of course, you can always call the nearest flight service station for any weather request, but certain flight service stations across the country have been set up to provide en route Flight Advisory Service, or EFOS. If you find that confusing, just remember that EFOS spelled backwards is safe. EFOS uses the universal call sign FlightWatch. Now, the whole purpose of FlightWatch is to give you actual weather and thunderstorm information along your route of flight. You can also request your immediate destination weather and forecast, but you don't want to file flight plans or get a lot of extraneous information on this frequency. On FlightWatch, all aircraft below 18,000 feet use frequency 122.0. Those at higher altitudes have different discrete frequencies. The coverage is available in the 48 states between 6 a.m. and 10 p.m. as long as you're at least 5,000 feet AGL. To get the service, just call FlightWatch, tell them who you are and the VOR you're closest to, and the nearest FlightWatch will get back to you. And if you're curious about which flight service stations provide FlightWatch in your area, look at the airport facility directory for your area and take a look inside at the chart on the inside back cover. FlightWatch is a very good place to get weather updates when you're flying IFR en route. Of course, be sure to get the controller's permission to temporarily leave his frequency for FlightWatch. It's also a great place to give and receive pilot reports, which, as you know, are referred to as PIREPs. Now, when a pilot makes a report of the weather that he or she is experiencing, it would stand to reason it would be the most current and therefore the most accurate information on existing weather conditions, including icing conditions. And PIREPs from you are always welcomed, especially if you encountered conditions different from your briefing or from the forecast. Now, PIREPs are not kept as an exclusive possession of the FlightWatch crowd. In addition to FlightWatch, PIREPs are collected over flight service station and ATC frequencies and are distributed as one of the text reports you can get from flight service or over Duet. So let's take a look at how the pilot report information is recorded. Now, PIREPs are divided into sections with slashes between the sections to identify the information that it's talking about. First of all, you can tell it's a pilot report because it starts with the letters UA. How does that come out to pilot report, you may ask? I don't know. Maybe it's because the FAA is thinking in terms of unreliable airmen, or possibly upper air. Regardless, it designates a pilot report. Now, to be really helpful to you, it would be nice to know where the pilot was when he made the report. The abbreviation OV stands for the location or over, and in this case, the pilot was relative to OKC or Oklahoma City on the 063 radial at 064 nautical miles, the 63-degree radial at a distance of 64 nautical miles. TM stands for time, and the time this pilot report was made was 1430 Zulu. FL stands for flight level or altitude, and the altitude of the aircraft was 6,000 feet, and that's 6,000 feet MSL. TP stands for type of aircraft, and in this case, the pilot was flying a Cessna 182. Now, TA stands for temperature, and the temperature was minus 4 degrees Celsius. And the wind direction and velocity, that's the WV there, was reported by the pilot as from 245 degrees at a velocity of 040 or 40 knots. Now, SK stands for sky. The sky conditions were broken clouds, and the pilot was BL between layers. Now the WX, or weather, that the pilot experienced was moderate rain. That's an RA with no plus and no minus. That makes it moderate. And he also encountered turbulence, TB, and the type of turbulence was moderate turbulence. By the way, you would report moderate turbulence when you have definite changes in the altitude and or attitude of your airplane, but the airplane remains in control at all times. You would report light turbulence when you have momentary, slight, erratic changes in your altitude or your attitude. And you would report severe turbulence when you have large, abrupt changes in your altitude and or attitude, possibly with the airplane momentarily out of control. And personally, that's one report I never want to have to make. PIREPs are very valuable because they let you know what's really happening between the weather reporting stations. Kind of takes the guesswork out of the weather.
Transcribed broadcast aviation weather 1500 Zulu observation unless otherwise stated. San Diego Lindbergh 900 scattered. Estimated ceiling 20,000 broken. Visibility 5.
This is another way to get weather information while you're en route. It's called a transcribed weather broadcast, or TWEB. What's a TWEB? It's simply a continuous tape recording of weather information, a weather briefing for specific routes of flight. It's broadcast over certain VOR stations and NDB stations. So how do you monitor the information on this continuous tape recording? First, you can find out which VOR or NDB stations broadcast to TWEB by looking on your low altitude en route chart. Take a look at the Flying Cloud VOR DME and notice the darkened circle with the white T. This tells you there's a TWEB broadcast on this frequency. Then simply tune your VOR to 111.8 and listen to the audio on your nav receiver. Now here's another way to get critical weather information. Very critical, in fact, as you can tell from its name. And that way is the Hazardous In-Flight Weather Advisory Service, or HIWAS. Now HIWAS is a continuous broadcast of SIGMETs, convective SIGMETs, AirMets, severe weather forecast alerts, and center weather advisories over selected VOR stations. What you hear on HIWAS is stuff that is really dangerous to your airplane. Not just routine information about route forecasts and winds aloft, but information about developing thunderstorms, spreading areas of fog, and other information that is truly hazardous or potentially hazardous for your flight. Now notice that wind shear advisories are included in the convective SIGMET. This means you will not hear any separate HIWAS reports regarding this potentially hazardous weather. And you will not hear any radar reports broadcast over HIWAS either. Now, how do you know which navigation stations will have HIWAS broadcast available? Well, again, you look at your low altitude en route chart. The black circle with the white H in the navigation aid frequency box, like here at Wichita, tells you there is a HIWAS broadcast over this frequency, 113.8 in this case. Just tune in the frequency on your radio and listen to the audio on your nav receiver. It's a good way to avoid nasty surprises. And now you know more about ways to stay connected to the weather gurus, even without a phone or a computer.